The topic of the day is still conservation of energy, but now we're adding this wrinkle. We're talking about situations where friction kind of messes with things and steals some joules away. So hopefully before starting this, you've gone through example one, which was just classic conservation of energy. Meg starts up high and not moving, so she's got gravitational energy. Then she ends up at the bottom of the hill, her lowest point, and moving, so she ends up with kinetic energy. So you should have watched the solution, but basically the gravitational gets converted to kinetic, and we can figure out how fast she's going at the bottom. Hopefully you've watched the video, but this one's a little bit trickier. Started off up high and moving. So start off with EG, ended up at the bottom with EK, but the math didn't work out. All of the EG wasn't converted into EK. The EG went into EK, plus there's a little bit left over. In that video I called it E missing. Sometimes we call it E lost, sometimes we call it E due to friction, but there was this extra friction that kind of showed up. That's the extra energy that was involved. Energy is always conserved. If we know how many joules we have at the beginning of a situation, we should be able to we should be able to figure out where all those joules end up later, and they should all still be there. However, when friction's involved, it gets a little bit messy. Sometimes we say that friction steals joules. It's not so much that the joules are gone forever, they're just in a new form that is difficult to take advantage of. In the example of that skier skiing down a hill with friction, friction heats things up. Like when you rub your hands together, the warmth of your hands is energy from the friction. When the skier slides down the hill, they would end up at the bottom a little bit slower, but some stuff in that system would be a little bit warmer. Maybe the skis are a little bit warmer, maybe some snow's melted, something would be a little bit warmer. That's the friction, that's the energy. We can account for those joules. They're just in the form of heat, let's say, instead of EK or EG. As an analogy, let's say you're given $1,000 to play with on the stock market, or to use on the stock market. I shouldn't say you're playing with the stock market. Maybe you got one of those Questrade or one of those accounts, and every time when you make a transaction, that service takes a $5 fee away from you. If you started with 1,000 and the service takes a $5 fee away from you, really you only end up converting $995 of your original 1,000 into the form that you wanted, into stocks. The $5, in a way, it's lost to you. You can't have it back. That's kind of what friction does. There's two ways to think about the accounting of that $5. Sometimes we could say that the initial energy gets converted to the final energy plus whatever is lost. So in this case, the original 1,000 equals the 995 plus 5. Sometimes the way people see it, they say, okay, no, it's a little bit different. Let's take our E initial and subtract what's lost. That tells us what we've got at the end. They would say take the 1,000, subtract the 5. That means we have 995 in the final form. Mathematically, those are equivalent. I really don't mind how you set it up, but just know that when friction's involved, less of the joules make it to a useful form in the end. There's a couple examples here. Example 3 is very, very similar to our skiing one. I just made it, no, it's still a skiing one. I thought it was a toboggan. If I give you how much energy is lost, can you figure out how fast it's going? So a little bit different, but the same concept. Question 4 is different again, so make sure you watch that solution. We can go a little bit further. Here, the video is there, but just to give you a sneak peek of example 4, the kid on the bike starts off with EK, and basically they skid to a stop, so they end up with no energy anymore, no EK, they didn't go uphill, so no EG, and some E lost. That's just a primer for that, but that video there has more detail on that one. Then to help you out, there's 3 there to try with answers. The worksheet that I've linked is the same worksheet you looked at last lesson. The first 4 questions were just straight up conservation of energy, and the last 4 questions are like these ones today where some joules get stolen away. And there is a check-in problem related to this. It'll be, if it's not there already, it'll be posted on our Google Classroom shortly. That's just a quick talk over about how to deal with friction. Basically, the bottom line is friction steals some joules away into a less useful form. You would account for it just like you would account for the service fee at a bank. You're going to take it off of what you started with, or you could add it to what you ended with. Give them a try, watch the solution videos, and as always, email if you have any questions.